I'll crack on because I know time is not our friend at the moment. But thanks to Mark, and I'm actually going to talk slightly more broadly than just the IBC project, just for a bit of context. But I'll come back and touch on that in a little bit. But I'm going to talk quite widely about what the BBC's been doing with 5G, and I'll rattle through it. So effectively, we're kind of interested in multiple areas of how we can use these emerging connectivity technologies. So obviously, how we make stuff, how we move stuff around, and how we distribute stuff. And we've been involved in a number of projects that supports these kind of three aspects of our business. But the first question we kind of get asked quite a lot is why. And the reality is we've been using kind of wireless links and wireless cameras for quite a while. We've been using analog links for the best part of 50, 60 years. We've then moved through to digital links, and those have been great. They've enabled us. So don't worry, there aren't 31 slides if you're wondering about that. There's a lot of hidden ones. But yeah, effectively, we've moved to digital, and that's given us a kind of a lot more capabilities in both our distribution and our production links. But actually, we're increasingly now doing more and more things using IP. And the reality is that the mobile industry, as everyone knows, is moving in that direction too. So we're quite interested in how we can bring these two worlds together. And next to that, and this is a brilliant slide from Qualcomm. Obviously, Spectrum is at a premium. We're big users of Spectrum. We use it not only for our distribution of content, which we tend to do down in the sub 700 megahertz space, but we also use it for a lot of kind of production activities, whether that's for shared spectrum for radio mics. We've got other data kicking around in contribution links in the 2.5. We've got radio cameras slightly higher up. We've actually got satellite comms and a whole bunch of other things where we use Spectrum. So we're quite familiar with using Spectrum, but we're kind of also concerned that if what's going to happen to this spectrum as we move forward in time. So that's driven us to kind of have lots of conversations, and those conversations are really kind of based on these three things: kind of either standards and regulation, test beds and trials, and partnerships. And these are really kind of the core pillars of what we're doing. And everything we're looking at a kind of over a period of 1 year, 3 year, 5 years. So we've got sort of very early tests and trials and industry engagement conversations that are happening kind of very short term, including the IBC accelerators. And we've got slightly longer term projects where we perhaps do a little bit more in-depth research or work with partners or academia to try and drive those things forward. So those for us are projects like 5G New Thinking and 5G Records, but also industry engagement with the EBU, who is a European Broadcasting Union. And then longer term, we're also having conversations with the standards bodies, ETSI and Ofcom and 3GP as well. So let's just really talk about those. I'm not going to go too deep into these, but there's lots of conversations that are happening in this kind of in stuff, and a lot of this is for us is about getting the landscape right, because while we recognise that the mobile industry's got its own set of kind of criteria and things like that, ours are slightly more challenging in some respects, especially when we look at production. And if we look at production, we've got a whole bunch of things that we're really interested in. So throughput, we're very uplink heavy, really interested in latency, timing and synchronization is really important to us as well. So if we've got two cameras, they both need to arrive at the receive point at the same point. And then when we get into the really interesting stuff around shared spectrum and types of network and rural and remote support and ad hoc and nomadic. So what I mean by that is that, quite often we want to spin something up, use it maybe for a day, a week, and then spin it down again. Whereas most mobile phone networks are designed to go up and then last for maybe 10 years, or factory networks are designed to go up for 10 years. And quite often we want to do that with as little notice as we can get. So we're kind of really interested in how we can perhaps utilize some of the shared spectrum to do that. And rural and remote is really important to us as well. Not all news or not all events happen in big cities, and a lot of the things that we do, if you look at Glastonbury, it doesn't sound very remote, but actually it's a real challenge for us every year when we have to go there, because it is a field in the middle of nowhere that suddenly becomes a festival site and then drops back again. Tea in the Park was another one we used to do up in Scotland. But a lot of these things are kind of, they grow and then they shrink back again. So what are we carrying? Well, lots of radio signals. We've got the obvious one where Bob so ably demonstrated earlier with the program video, but we're also really interested in reverse signals. And this is something that 5G and IP particularly can bring to us, in that traditionally we'd have to have separate radio layers for all of these different signals, ranging from VHF all the way up to Wi-Fi and above. And actually, if we can use IP, can we put all of these into one signal? So we're looking at that. But we're also looking at the types of networks, and there's a lot of technical abbreviations on here, but essentially we've got the differences between the public networks on the left-hand side and the standalone non-public networks on the right. And we will use the public networks. We will use those for news gathering, for contribution links, for people using coming in to do presentations like Mark's just done, but we've got no control over those. They're very ad hoc, and but they've got really good global coverage. And at the other end, we've got potential to own and operate our own Open RAN standalone non-public networks, which give us lots of control, but they do require more planning, and they're going to be very localized. And then we've got all of these other things that we can do in between, and so we're exploring all of those. And how are we doing it? Really, tests and trials. So these are the things that we're looking at, really. Sort of non-public networks, those are really interesting to us, as I said earlier. Codecs and transport, this is a really contentious one. You'd think it'd just be easy, I'm just going to put video in, but the reality is that we need to compress that video to carry it over these wireless networks, and how we compress that video has a major impact, and quite often compression adds latency and adds time to do that. So we need to make sure we're doing that, but still maintaining the right quality. Audio is particularly challenging. The reason for that is mostly around latency and extremely low latency links, and as mentioned, timing. And then when we get down to the bottom, the kind of shared spectrum access. So, we don't want to buy spectrum for a year and then lock out a site when we're only going to use it for a day or a week. And quite often, because the way we want to work, we've got quite relatively small uplink power, so we can actually work in a slightly different way to the way that the PLMNs are working, but we need to basically find out the way that we can support that within the shared spectrum environment and the regulation environment. So we're having conversations with people around that, and Ofcom and the like. And then finally, just to gallop through some of these, we're doing a lot of projects and partnerships, not least of which is the great work that we're doing with Strathclyde that's been talked about today, but also with industry bodies such as the EBU, 5G MAG, DCMS and UK 5G, but also we're involved in a couple of H2020 European projects. But for us, the accelerators that Mark's talked about, those have been really good at actually bringing the current state of the art together to be able to really kind of test stuff from different manufacturers in different ways in a way that actually mimics the production environment a lot more closely than you'd think. And what's really important to us is not the individual technology. We're looking at, there will be one thing, the wireless camera that we do over 5G, but as Mark says, we're also looking at the potential of LEO, how we bring that together and integrate that into cloud working workflows and processes, and not only that, kind of multiple cloud. And this is really the heart of what we're going to be doing and what we're going to be showing at IBC this year. And it's going to be really exciting. We'll be doing a lot of more online work on it. And if you are at IBC, then do pop by and say hi, and you'll be able to see some of this kit in action. I think that's probably all I've got time for. So I'm going to hand back to Bob.